Let's understand very useful item, data frames. Let's step into what is Python. Okay, let's understand what is Python first, and then we'll understand what is something called data frame. Okay, what is that? Data frame. And then we'll continue how to use it slowly in our actual examples. First, what is exactly Python? Let's step into it. Python for us as a data engineer, it's a ETL environment. Python has a lot of shades. We have Python for programming, Python for machine learning, Python for AI, Python for IoT, deep learning, so on. We are into ETL. We use Python from today to read or extract data from any data source, transform or format the data, and load the data using Python into required target, either DBFS or a data warehouse or any other destination. Basically, Python should be seen like a ETL environment. In our journey, we have something called Spark SQL. In addition to Python, Spark SQL is an analytic environment to perform select and aggregate operations. Using Spark SQL, we have limited DML and DDL operations. Remember, more flexible DML, DDL operations we can do using Python. Spark SQL is great for analytics. Python is great for DML, DDL. So we are going to blend them together in our examples from today. This Python operates on big data, any type of data, any size, using something called data frames. What is that? Data frames, a new keyword for rest of our classes. Data frames are Spark cluster memory objects to represent any data in a tabular format for easier, faster operations. Let's make it simple. You have some guests at your home. You would like to serve your handmade coffee, right? So coffee in cup is the actual object to be served. You got some guests at your home, maybe your colleagues or neighbors or well-wishers. You would like to serve them coffee. You get them in a tray, right? 1 or 2 trays. Those trays are the data frames here to carry the data in a safe way, careful way. Yes, data frames are nothing but your trays to serve the coffee. Here, coffee is your data. Extract from kitchen, load it to the hall or your waiting room or drying room or whatever place. Data frames are the data carriers, remember. In a two-dimensional structure, a data frame is a data structure that organizes data in two-dimensional table of rows and columns, just like a spreadsheet. Something like this. So table or data frame is partitioned across servers in a data center. Why? Because we are talking about cluster. Cluster means multiple nodes. So data is auto partition because a big magic tray spanned across multiple say houses or multiple rooms in a group house, something like that. It's a cluster. It's a magic tray. So data is auto partitioned. It can withhold huge volumes of data. Terabytes and petabytes of data can be held in a single data frame. It's not a regular memory object. It's a big database or data memory object, big Spark cluster memory object. It can store any amount of data, any type of data. Remember, in memory, which memory? Spark cluster memory. This should remind us about our previous class, configuring Spark cluster. We got some memory, 14 GB RAM and 4 processor cores. So that particular cluster memory, we are now configuring this data frame. For now, it's only 4 GB RAM for now. Later classes, we are going to increase it multifold. The concept of data frame is common across many frameworks, including Python. They are similar to memory tables, also called magic tables you have in your regular SQL database environment. Using data frames, we can filter, we can group, we can selectively project the data to required destinations. We can extract the data using data frame, perform faster transformations, and load any type of data into any destination. Here, there is a brand of data frame called Pandas data frame. External predefined library called Pandas. External predefined library. What is exactly Pandas? Let's see. Pandas is a software library mainly for data modifications and data analysis. So we are going to use this Pandas library from today for the purpose of our day-to-day ETL, DDL activities. Why we need it? Why it is so famous? Yes, regular data frames cannot handle terabytes of data efficiently. They can handle, but not as efficient as we experience with Pandas. So Pandas data frames are damn fast, very fast. And one more thing, with Pandas, the data frame content is automatically indexed. That's another great advantage. Let's get started with our examples now. So just like we have SQL inside Microsoft SQL Server called TSQL, also called as MS SQL. The implementation of Python inside Apache Spark is called PySpark. So Python plus Spark. Python implementation inside Spark is called PySpark. Here in PySpark, the data frames can be either defined manually or created automatically using data extraction utilities. We have examples lined up for both manual and automation of data frame creations. So let's step into examples. For that, we have basic vocabulary.